Welcome to the Explainer. Today, we're heating things up, literally, to uncover a hidden transformation that makes copper one of the most useful materials on the planet. It's a process that takes a brittle, useless metal and makes it incredibly workable.
All right, let's kick things off with something you've probably done yourself, right? You grab a paper clip, maybe a bit of wire, and you bend it. It's easy. You bend it back, it gets a little tougher. You keep going back and forth, and then, snap, it breaks. So what's actually happening inside that metal to make it do that?
Well, the answer comes down to something called work hardening. And while harder might sound like a good thing, it actually creates a huge problem if you're trying to, make anything with copper.
See, every single time you bend that wire, you're not just changing its shape, you are fundamentally messing with its internal structure. The tiny crystals inside get all stretched out and tangled up, creating this microscopic traffic jam of defects. It literally gets harder and harder for the atoms to move around.
And that's the real issue here. This hardened, stressed-out copper is basically useless for a lot of jobs. You can't bend it into a pipe, you can't draw it into a super thin wire. If you try, it's just going to crack and fail on you.
So, what if there was a reset button? A way to tell all those stressed-out atoms to just chill out, undoing all that damage, and bringing the copper back to its original, soft, easy-to-work-with state. Well, luckily for us, there is.
And that reset button is called annealing. It's this incredibly precise heat treatment that gives copper a complete do-over. By heating it up, letting it soak, and then cooling it down just right, you can bring that brittle metal roaring back to life.
And the difference is, it's night and day. On one side, you've got that cold-worked copper. It's hard, it's brittle, it's stressed out. But on the other side, after annealing, it's a whole new material. Soft, pliable, and basically ready for anything.
So, how does this fiery rebirth actually work? What is happening inside that furnace to cause such a massive change? Let's zoom way in, down to the microscopic level, and see what's going on.
The whole process happens in 3 really carefully controlled stages. First, you heat the copper, slowly, up to a pretty specific temperature. Then comes the holding phase, where it just hangs out or soaks at that high temp for a while. This is where the magic happens. And finally, you cool it down super slowly to lock in all those good changes.
I love this analogy because it's spot on. Work hardening is like shoving all the atoms into a crowded, stressful room. But annealing, that's like opening up all the doors and windows and telling everyone, hey, relax, spread out. The heat gives the atoms the energy they need to move around, fix the defects, and form new, big, perfect crystals.
And if you look at the hard science, you can see exactly what's changing. Before annealing, the metal's grains are small and stressed. Afterwards, they're big and relaxed. The number of those traffic jam defects we talked about, the dislocations, it just plummets. And most importantly, all that internal stress is just gone.
Okay, so we get the process, but what are the results? Let's look at the incredible, totally measurable proof of this transformation. This isn't just theory. The data shows us a material that has been completely reborn. First up, let's talk about hardness. Just look at this chart. The control copper, that's our baseline. Now, when you work it, see how that bar shoots way up? That's work hardening in action. But then, look what happens after annealing. The hardness just plummets, making it even softer than when we started. How cool is that?
Next up is ductility, which is basically its ability to stretch without snapping. And this data is just fascinating. As you crank up the annealing temperature, watch what happens to that elongation number. It just climbs and climbs, hitting this perfect sweet spot around 350 degrees Celsius.
Let's just pause on that for a second. An increase of over 500%. That is a massive, massive change. It means the annealed copper can be stretched and bent into all sorts of complicated shapes that would have been totally impossible before.
But wait, there's more. The benefits don't even stop there. By getting rid of all that stress and all those defects, annealing clears a superhighway for electrons to travel. That relaxed structure means electric can flow way more freely, which gives its conductivity a major boost.
And what this all leads to is, oh, it's pretty incredible. With the right kind of advanced annealing, you can get copper's conductivity to over 99% of the international standard. That's the IACS. We're talking about a material that is just a stone's throw away from being a perfect electrical conductor.
Now, this isn't just some neat lab trick. This transformed, superpowered material is absolutely essential to our modern world. You are interacting with it every single day, probably without even realizing it. Think about it. The electrical wires inside the walls of your house, they need to be flexible and superconductive. That's annealed copper. The pipes for your plumbing that have to bend around corners, annealed copper. It's in roofing, it's in your phone circuit boards, it is everywhere. So in the end, annealing delivers this amazing 1-2 punch. For the people making stuff, it makes copper way easier to work with, which saves a ton of time and money. And for us, the consumers, it means we get products that are more reliable, more efficient, and just plain built to last longer. It's really a fantastic example of how we can intelligently work with materials on a microscopic level. We can take something that's been pushed to its breaking point and, with just some heat and some time, bring it back better than ever. So that really leaves us with something to think about, doesn't it? Annealing. It's this hidden process, but it has this massive impact on our world. It kind of makes you wonder, what other invisible processes, what other little bits of scientific magic are quietly working all around us to make our modern lives possible? Thanks for digging into this with me on The Explainer.